to get. So it's all here. It's two pieces, two integration by parts. All right, final answer. Is, look, don't be afraid to use up paper, okay? The planet is just fine. There's plenty of paper. All right, so distribute here. I think we're going to finish ourselves off before the planet cares, right? We'll probably finish ourselves off before we run out of paper, don't you think? I think so. X cosine 4x. So that's just, right? This is just arithmetic. Negative 1/2 times that, what's that? Negative 1/32. And then sine 4x plus c. There it is. If I differentiate that, I should get x squared sine, I forgot what it was. Was it sine? X squared sine 4x? Cosine 4x. No, because we already did all the antiderivatives already. All right, that's our answer. We'd box it. Now, just because there are skeptics, I'm going to differentiate it, but I'm doing it quick, okay? Product rule here, derivative of that is 1/2 x sine 4x plus 4 cosine 4x times 1/4 x squared plus, here's another product, so I'm going to have 1/8 cosine 4x plus 1/4, or not 1/4, 4 sine 4x times 1/8 x minus, a 4 is going to pop out of that, so I'm going to have 4 over 32, which is 1/8 sine 4x, not sine, cosine 4x. All right. Wow, okay, this cancels with this. Did I forget my x here? No, this right here, look at this. 4 over 8 is what? 1/2? So isn't this x sine 4x? Half, right? Half.
Which is all the way out there.
Which is all the way out there.
So the 1/2 stands?
You have 2 1/2s.
2 1/2, so you go together and it becomes 1x sine 4x. Uh-oh. X sine 4x. Hold on, those should have canceled. Hold on, did I lose a negative somewhere? Go back. When I wrote that down, did I miss a negative on this?
Yeah.
I think I did. Wasn't it negative? Go flip back.
The answer is 1/4 x squared.
1/4. No?
Your first one was positive.
Yeah, but this one's not negative, right?
I think the minus 1/2 should have been a plus 1/2.
Where?
Right there, because when we use
Are you taking the derivative of it?
no, like
We're taking the derivative.
where it says minus 1/2.
Oh, sorry, my fault. Look, I see it now.
Yeah, that's 2.
The derivative of cosine, right? What's the derivative of cosine? Negative sine. Okay, there. That's negative. My fault. So then this whole thing will cancel with this whole thing. And the only thing left after this and this cancel is x squared cosine 4x. It works. It works. I worked too fast through it, sorry. All right. Good. Good job, Laura. Who's up? No more volunteers? I guess I'm going to just pick somebody here. Nobody's feeling good today? I'm going to go with some names I'm not familiar with. How about Felix? Where's Felix? Okay, since I don't know Felix. All right, Felix, I'm going to give you one. I anticipate you might have trouble with this. Let's see. So let's let Felix think about this for a minute. That's natural log of x, okay? So if you have any doubt, that x lives in the natural log.
Is it possible to make like the u just the ln of x and the dv just dx? I don't know if that would work.
Absolutely, you can do that. In fact, that's about all you can do, all right? Everyone see that? You have a product here, right? It's natural log of x times dx. dv has to have dx in it. So the only choice is dx itself. And then the natural log x must go here. But everyone clear that you cannot separate natural log and x? Like that's not like ln times x, so you can't like, okay. So we can't do that. So yeah, that's good, go with it. Go with it, see what happens. So what would your du be, Felix? So derivative of natural log x.
It's 1 over x.
1 over x, and then we'll just always throw dx, right? And then when you integrate this, this is really like a 1. So what's the antiderivative of 1 with respect to x? X. Y'all agree? Now look at voodoo. Look at the diagonal. Do you like it? Yeah, that's actually really clean, isn't it? Does everyone see that when you do voodoo, they're going to go away? The x and the 1 over x are going to cancel? All right, Felix, let's use the formula. Ultraviolet minus voodoo. So how do you want me to write this?
X ln x
X ln x.
minus the integral of
Let's go ahead and write it out, even though it's going to cancel. Let's write it out.
x over x dx.
X times, I'm going to go 1 over x dx. But what you said would have been right. Everyone agree? And then the 1 over x and the x turn into a 1. So this is really x ln x minus integral of 1 dx. And Felix, didn't we just take the antiderivative of 1 just a second ago? It was x, right? So this is just x ln x minus x plus c.
Wouldn't that be integral, isn't it x dx, because it's v times dv?
Yeah, I'm using 1. It's, no, not x, sorry. It's v is x, right? Times 1 over x dx. So these two right here, it's like they cancel out and you get your 1. Huh, that's interesting. Now, I'm not okay with you writing things on your formula sheet, okay? That way everyone has the same formulas. You are allowed to write this one, though. Right? So if you want, on your formula sheet, you may add integral natural log x dx equals x ln x minus x plus c. I'll let you put that there. Because, I mean, we all know what the derivative of natural log is, right? Derivative of natural log is 1 over x, but what's the antiderivative of natural log? Well, there it is. That's what it is. We could check this one, couldn't we? We could? Like, there's a product right there. Derivative of this would be 1 times natural log x plus derivative of natural log of x, which is 1 over x, times x, and then minus derivative of x, which is 1. And when you do this, this turns into a 1 minus 1. That goes away, and you get natural log x. It works, okay? I'm just trying to convince you quickly that it does work. All right, nice, Felix. Okay. Well, Felix, give me a number between 1 and 13. Where's Felix? 9? Okay. 0, 2, 3, 4, 5, 6, 7, 8, 9. Mohammed, you're up. That's arc sine of pi x. Pi is a constant, right? Pi is you may as well have put 2x there, right? Do you see product anywhere, like multiplication?
Can I equals pi x?
This can't be separated from the arc sine because it's inside of it. This is not multiplication. So this is almost like, remember we just had natural log x? Like you couldn't peel it off? Same thing here. This is stuck to this. So the only multiplication in the entire problem really is that right there. So does that help? Yeah, you really only have one choice for the u. The u is going to be arc sine of pi x. You got to grab the whole thing, and that forces your dv to be dx. So this is very much like the last one, right? Your only hope of doing this problem is if you know what the derivative of this is. But we do, right? We know the derivative of arc sine? Yeah? Okay, so let's see. The derivative of arc sine of something is?
Square root of 1 minus pi x.
Okay, so 1 over square root of 1 minus pi x, that quantity squared. Keep going.
Times x
Times close, not x though.
pi
Times pi
times dx.
dx. Perfect. Everyone see that? Chain rule would require that you, after you do the formula for arc sine, you then go take derivative of pi x, which is pi. So you're going to get that pi to pop out of there. Good. Now the other one should be easier to get v. V is x. Ooh, okay. Look at that diagonal. That doesn't look pretty, does it? The diagonal? But that was really your only choice. So let's see if we can get anywhere with this. Ultraviolet
Sine inverse of pi x.
times this, right? So I'll throw that x in front. All right. Minus integral that and that, right?
X times 1 over square root of 1 minus pi x quantity square times pi dx.
All right, good.
Can't we clean that up and put pi?
Yeah, now would be where we pull constants out. So is that all right if we pull that constant out? I'm going to rewrite the whole thing. I don't want to get lazy here. That's my table over there. So that equals x arc sine pi x minus pi integral.
Multiplies x.
You want to put it on top or just leave it there? It doesn't matter. I'll put it on top. Now when you look at this, what you're left with here, I'm going to let you think about that for a second. All right. So Mohammed's thinking about this. That looks nasty, doesn't it? Any ideas? Okay, how though? How are you going to integrate that? So are you thinking the u sub again? Or not u sub, the integration by parts again? Maybe. So let's think through that. If you did integration by parts, right? Your most likely candidate for your u would be x here, wouldn't it? And then your dv would have to be everything else that's here. And then what's going to wind up happening is you differentiate down, you're going to get dx. When you integrate this up, you're going to have the arc sine back. And so what's going to wind up happening is that you're going to get arc sine over here, and It's not going to help. You're going to get into this circular thing going. And the reason why you're going to run into that circular, oh wait, hold on. Yeah. The reason why this is going to cause trouble is because you can do it another way. This can be done a different way. So what's the only other way we know? Substitution. So do you see anything there and its derivative? Pi x squared. You can grab the whole thing, right? Can't you? In fact, look, I like this instead. Get rid of this for a second. Look at that as pi squared x squared. And then you still have the 1 minus in front, right? If I asked you to take the derivative of this, what would you get? 0? Minus pi squared stays. It's a constant. Derivative of x squared is 2x. So if you take the derivative of this, you're going to get negative, the 2, the pi squared still there, x, right? That's the derivative of this whole thing. And guess what? X to the first power is right here. You're off by a constant. This is going to be a basic u sub. That's where we are. Does everyone understand that? All right. Let's keep going then. So I'm going to do some scratch work here on the side. I'm going to leave all that right there. My scratch work that I'm going to do over here is to try and figure out just what this integral of x over square root of 1 minus, I like this pi squared x squared. Is that all right with everyone?
Yeah.
I'm just focusing all my attention on this piece right here. I'm going to deal with the negative pi that's in front of it in a little while. All right, so u here is going to be 1 minus. Let's grab the whole thing. Basic u substitution. Derivative of this, we just said, was negative 2 pi squared x dx. Just like we did last class and for homework, we isolate, right? We're going to isolate this x dx. So I need to divide both sides by negative 2 pi squared, so it'll look something like this. X dx, sorry. And I believe, Mohammed, now you can rewrite the whole problem, can't you? So what is that whole problem going to rewrite into? So this is going to be integral. That x dx is going to be all this stuff, right? But you'll still have 1 over square root of, you said it, right? U. And then 1 over negative 2 pi squared times du. I'd like to pull the constant out. So all that is just coming out. And then 1 over root u is the same as u to the negative 1/2. And that's just power rule, isn't it? So the antiderivative of that, I bring my constant for the ride, and then I add 1 to this, and then do my thing. So it'll be what? 2 u to the 1/2. Plus a constant, but. And what was u, Mohammed? This right here, okay? All right. Anybody have a question as to what I've done? Are you starting to get an appreciation for the magnitude of the problems that you're going to be facing? Integration by parts with possible substitution, keeping track of all these little details. Yes?
So you didn't include the pi up front.
I'm about to do that right now. So I'm ready to go to my final answer. Let me rewrite this as negative 1 over 2 pi squared. Let me go, oh,